Our planet is a blue marble, a world of water. Yet what we see is only the surface of a vast mystery. Beneath the waves lies the deep ocean, a realm more alien and less understood than the surface of the moon. This is Earth's last true wilderness, a frontier that challenges our ingenuity and curiosity. We have mapped Mars and Venus in detail, but 95% of our own ocean remains unexplored. This hidden kingdom holds untold stories of life, geology, and the history of our world. In the deep, sunlight never reaches, and the rules of life are rewritten. Every dive and every image from the abyss is a hard-won victory against immense natural forces. The creatures and landscapes there are more fantastical than we could imagine, reminding us that nature's creativity is boundless. The deep ocean promises answers to fundamental questions. How did life begin? What are the limits of life? How is this hidden world connected to our survival? The journey into the deep is a vital quest for knowledge, one that holds the key to our future. The greatest exploration is not in the stars, but right here, beneath the waves. To understand why the ocean remains mysterious, we must grasp its sheer scale. The oceans are colossal, containing over 321 million cubic miles of water, enough to submerge all land on Earth within the Pacific alone. The average depth is over 12,000 feet, but the seafloor is anything but flat. Towering mountains, vast plains, and deep trenches like the Mariana Trench create a world of staggering complexity. The Challenger Deep plunges nearly 36,000 feet. Mount Everest would be buried under a mile of water here. The ocean is layered into zones: the sunlit euphotic zone, the twilight zone, and the midnight zone, a world of perpetual night that makes up most of the ocean's volume. Mapping the ocean floor is far harder than mapping Mars. Satellites can't see through water, so ships must painstakingly use sonar. To map the entire ocean with detail would take hundreds of ships' centuries to complete. The ocean's vastness preserves its mysteries, making it the ultimate, unexplored frontier. Its scale is both a barrier and a guardian of secrets. We have only just begun to scratch the surface. One of the greatest barriers to exploring the deep ocean is the immense, bone-crushing pressure. For every 10 meters you descend, pressure increases by 1 atmosphere. In the Mariana Trench, it's over 1,000 times surface pressure. This force would instantly crush an unprotected human, or a flawed machine. Even advanced submarines require thick titanium hulls to survive. A tiny flaw can mean instant destruction. Every piece of equipment, cameras, sensors, sample containers, must be engineered to withstand this relentless force. Collecting samples is a complex challenge. Deep-sea organisms must be kept pressurized or they'll be destroyed on ascent. Life in the deep has evolved remarkable adaptations. No air-filled spaces, gelatinous bodies and internal pressures matching the outside. These creatures thrive where we could not survive, a testament to life's adaptability. The deep ocean's pressure shapes everything: technology, exploration, and the very forms of life. Each discovery is a triumph over nature's most formidable barrier. The deep is a world where only the extraordinary endures. Beyond crushing pressure, the deep ocean is defined by absolute darkness. Sunlight fades quickly. By 200 meters, photosynthesis ends, and by 1,000 meters, all light is gone. Most of the ocean exists in perpetual night, making exploration a challenge for our sight-dependent species. Our vehicles must bring their own lights, illuminating only small patches of the abyss at a time. In this darkness, many creatures have lost their sight, relying on other senses, while others have evolved enormous sensitive eyes. But the most magical adaptation is bioluminescence, life creating its own light. Countless deep-sea creatures glow, using light to hunt, hide, attract mates, or communicate. The abyss becomes a silent, dazzling light show, a living language in the dark. Exploring the deep means not just shining our lights, but witnessing the secret glow of its inhabitants. In the deep, darkness is not emptiness, it's alive with wonder. To overcome the deep's challenges, we've built remarkable tools: our eyes and hands in the abyss. Sonar, using sound waves, maps the seafloor's hidden mountains and canyons. For close-up exploration, we deploy remotely operated vehicles, or ROVs, robotic submarines tethered to ships piloted in real time. ROVs are equipped with high-definition cameras, robotic arms and scientific sensors, capturing images and samples from places humans can't reach. These machines can work for days in conditions too dangerous for people. Autonomous underwater vehicles, or AUVs, are untethered and pre-programmed, mapping vast areas or collecting data independently. AUVs are ideal for broad surveys, even under polar ice. Together, ROVs and AUVs are pulling back the curtain on the ocean's deepest secrets. Technology is our bridge to the unknown, revealing a world once beyond imagination. Each new tool brings us closer to understanding the abyss. While robots do much of the work, there's no substitute for human presence at the scene of discovery. Human-occupied vehicles, or submersibles, carry scientists to the ocean's depths inside titanium spheres built to withstand crushing pressure. Through thick viewports, they witness alien landscapes firsthand, guiding the pilot to points of interest and collecting samples. The descent is a journey from blue to black, ending in a world no human has seen before. Being there in person allows for intuition and flexibility that machines can't match. But submersibles are expensive and risky, so ROVs and AUVs are vital for deeper, longer and riskier missions. Modern exploration combines these technologies. AUVs survey, ROVs investigate, and submersibles make the most compelling dives. This partnership between human and robot is unlocking the ocean's mysteries. Each approach has its strengths, but together, they are unstoppable. The future of exploration is a team effort. Human curiosity, robotic endurance. The deep ocean reveals life stranger than we ever imagined. The anglerfish lures prey with a glowing rod on its head, hunting in total darkness. The vampire squid turns itself inside out and releases glowing mucus to escape predators. The barrelly fish has a transparent head and eyes that look upward for prey. Around hydrothermal vents, life thrives without sunlight. Bacteria use toxic chemicals for energy, supporting entire ecosystems. Giant tube worms, ghostly crabs and shrimp crowd these vents, living off chemosynthetic bacteria. These discoveries shattered our assumptions about life's dependence on sunlight. The deep's bizarre creatures show that life can adapt to the most extreme conditions. These oases hint that life could exist in similar environments on other worlds. The deep ocean is a living laboratory of evolution's wildest experiments. Exploring the deep isn't just about curiosity, it's vital for our planet's health and our own future. The ocean regulates climate, circulates heat, and absorbs carbon dioxide, buffering us from climate change. Understanding the deep's role in storing heat and carbon is crucial for predicting our planet's future. The deep is a treasure trove of resources, unique genes, enzymes, and compounds with potential for medicine and industry. Deep-sea organisms inspire new antibiotics, cancer treatments, and biofuels. The deep supports global fisheries. Many important species depend on its ecosystems. Damage to the deep could ripple up to our dinner plates and threaten food security. The seafloor holds Earth's geological history and clues to life's origins. The deep ocean is not distant. It's an integral part of our life support system. Its fate is tied to ours. Its secrets are vital for our survival. We live in a golden age of discovery, with technology opening new windows into the ocean's hidden world. But as we explore, we must also protect. The deep is already threatened by climate change, pollution, and mining. Our ignorance is the greatest danger. We cannot protect what we do not understand. If we destroy these ecosystems before we know them, we lose species, knowledge, and potential benefits forever. Exploration and conservation must go hand in hand. We must establish protected areas, manage resources sustainably, and minimize our impact. The ocean is the cradle of life and the engine of our climate. For generations we've wondered what lies beneath. Now we can find out. We have a duty to explore, understand, and protect this vital part of our planet. The journey of discovery is far from over. The deep ocean awaits. Its future and ours depend on what we do next.